So I'll go ahead and just record just this piece of it for now. So let's look at 5.3 number. Well, let me start with 21 in 5.3, which is actually, I think, the very last problem on this. Hey guys, if you haven't tried these yet, of course, you're more than welcome to write down the solutions as we're working them out, but you really should make sure that you truly understand them. And so I'd recommend that you, even though you'll already have the answers, you should maybe sit with these problems a little bit on your own and just make sure you totally understand them. On this 21, there's an inner product that's one of the first questions that people usually have is they're like, where's the formula? Well, the formula is like 3 lines above the question, but you have to find it. So it says 5A11B11 plus 2A12B12 plus 3A21B21, and then plus 5A22B22. So this is going to be given to us. Remember that unless it's the standard dot product on our end, that formula has to be given for you to be able to do any problems. And then here's what they're going to ask us to do. We're going to take the matrix A1, which is 1, -1, 2, 1. And then we'll take another matrix A2, which is 2, -3, 4, and 1. And they just want us to create an orthogonal basis out of those vectors, right? So you're going to replace, remember the whole idea of the Gram-Schmidt process? You start with some vectors that are a basis, v1, v2, v3, whatever, however many you have, and you replace those with w1, w2, w3, and so on. So these are basically the original vectors v1 and v2. And they are a basis for whatever they span. So there is a subspace here that's just the span of these two vectors, and that's what we're finding an orthogonal basis for when we apply the Gram-Schmidt process. So I'll just remind you guys, I'm going to give you the Gram-Schmidt formulas anytime I ask you on an exam. But the point is W1 is just the same as B1. So it's just the first matrix. We don't even have to think very hard about that. And then the second vector, which is going to be W2, I'll just remind you the general formula first. Again, I'll be giving this to you, so you don't need to memorize it, but it's V2 minus, and then what we do is we create a fraction where we take in the numerator the inner product of V2 with W1, and in the denominator we do the norm of W1 squared, and then that gets multiplied by W1. Okay, so this is going to be my second vector. And all you really have to do is just calculate everything. So let's write down V2, which is 2, -3, 4, and 1. And then minus some fraction of W1, which was 1, -1, 2, and 1. So I'm just filling in the blanks here. So in a moment, we'll have to do a subtraction. But before we can get to that, we have to fill in the numerator and denominator of this piece right here. This is really where the most of the work is, just figuring out these numbers right here. To figure out these numbers, guys, you're going to use the formula at the top of the board, right? So if I want to know what's the inner product of V2 with W1, that's these two vectors, right? So how does it work? Well, the formula tells you how to do it. 5 times A11 times B11, right? So that's 5 times 1 times 2, which is, so let's just start working this one out. This is 5 times 1 times 2 is 10. And then plus A12 times B12, that's -1 and -3, which is 3 times 2, that's 6. Okay, it's just calculating it. Then the third term is 2 times 4 with a 3 in front of it. So 2 times 4 times 3 is 24. Okay, and then finally, the A22 times B22 is just 1, and there's a 5 in front of that. So you're going to get this kind of a number, and that adds up to 45. So that number is what goes right there on the top of that fraction. Just put a 45 in there, and you're in good shape. All right, the denominator is the norm of W1 squared. I'll remind you again that that's literally just the inner product of W1 with itself. W1 is this vector here. So I'm dotting it with itself using that formula at the top. So it's going to be 5 times 1 times 1. It's 5 plus 2 times -1 times -1. That will be 2. Plus 3 times 2 times 2, which is 12. And then plus 5 times 1, which is 5. You add all of that up and you get 24. Okay, and this can be reduced a little bit if it helps. It's just 15/8. And now you actually just have to subtract. You just have to do this subtraction. This is not terribly interesting because you've got some fractions here, but so you're going to get 2, -3, 4, and 1. And from that, you have to now subtract 15/8, -15/8, 30/8, and 15/8. These numbers are just coming from taking the 15/8 and multiplying it into the 4 entries of the matrix here. Right, so this is what you would end up with right here. And now this could be, well, you have to subtract some fractions. Can I let you guys do that one? Keep in mind, the back of the book might have a different answer because there's never a unique answer for a basis. I'm guessing that they have the same answer as what I have, because guess who wrote the back of the book? Me. So probably I did it the same way then as I just showed you guys right now, but there's always a chance that it could be slightly off. Does everybody understand that? The key thing, usually when people get stuck on this problem, that they're looking at this thing kind of cross-eyed, like, where's that coming from? And I have to just remind them, well, yeah, I'm just giving that to you, right? You have to live with whatever inner product I've created for that problem. So, and I am likely to do this on the exam, by the way. It's probably not just going to be the regular dot product all the way through. At some point, I'm going to ask you to use some kind of an inner product that maybe has some funky numbers in it or something like that. We've certainly seen a lot of examples of that. So be ready for that as well. Make sure you practice a little bit. Okay, so that's 21. The other one from this section is number 18. And then, let's see, 18 is kind of similar to one that I did last week, but let's just write it down. This one is involving polynomials. So f1 of x is 1, f2 of x is x, and f3 of x is x squared. So just your standard basis vectors for the world of polynomials. And then they give you this vector space, which is an interval with an a and a b value. And they give you a as 0 and b as 1. All that that's telling you is, if you remember that the usual inner product here, and they do reference it in the question, so you know you're supposed to use this one, but this is going to be the integral from a to b of f of x, g of x, dx. It's just that standard integration like so. And because a is 0 and b is 1, I guess I could put those numbers in here. So we have 0 here and 1. Okay, and what are they asking for? They want an orthogonal basis again. An orthogonal basis. So just like before, guys, these vectors are the original basis for what we're looking at, v1, v2, v3. And we just need to orthogonalize those vectors. So the w1, as we already know, is just the same as v1. Good to go. Okay, so we don't have to work too hard yet. w2, all right, now we have to use the formula. It's the same formula that we were using over here. Okay, so let's write it out. I'll do this fairly quickly. I'm going to take v2 as x. I'm going to subtract some fraction of w1, and w1 is just 1. This fraction is just going to have integrals on the top and on the bottom. They're all going to go from 0 to 1. On the top, I have to do the inner product of V2, which is x, with W1, which is 1. So this is just the integral of x dx. Okay, and then the denominator is just the integral of 1 times 1 dx, right? So this is the inner product of 1 with itself. Let me know if I'm going too fast. It's one of those things where I can kind of go on autopilot on this, but it's mostly just crunching numbers, doing calculations here. So this just becomes x minus, let's do these integrals in our head. The integral of x is just 1/2 of x squared, which we have to evaluate from 0 to 1. That's just going to give you a 1/2 on top. And then the integral of dx from 0 to 1 is just 1. And that's times 1. So your second vector is x minus 1/2. That's W2. Super easy. The nice thing here is the integrals are not hard, so you can do them pretty much in your head most of the time. And then finally, we have a W3. W3 is going to be V3, which is x squared, minus, I'll make some fraction that has a 1 on the end of it, and then there'll be another fraction because we have to subtract off a term for x minus 1/2 now as well. And so you will have to fill in these integrals. I think I'll write down the integrals and then let you calculate them, if that's okay. So the first, they're all going from 0 to 1. Every single one of these is an integral from 0 to 1. Not too bad to get that figured out. The first one here, this is the inner product of x squared with 1. So that'll be an integral of x squared dx. The denominator is just like before, 1 times 1 dx. And then over here, I have to do the inner product of V3 with W2. So that's going to be x squared with x minus 1/2. And the denominator will be x minus 1/2 squared dx. So these are all the integrals you have to do. I would recommend just multiplying these out to do the integrals, and probably the easiest way to get it. And evaluating from those limits is super easy. From 0 to 1. So I'll let you guys figure out this number and this number and this number and this number. Those are the numbers you need. And if you're worried about it or not sure you got it right, you can obviously check with me later on tonight, and I'll be glad to help you out with that. Okay. Is that good enough? I think I'm just gonna leave it at that and quit a couple minutes early today. I think the problem 7, I'm going to have you just watch that on my other classes video. I'll send out an email after my second class today with some links to the things that might help you. If you don't want to do that, just stop by my office hours. I'll be happy to help you out with the rest of the homework as well. Okay.